Hello everyone, good to see you again. Uh, I call myself Mr. U.S. Patil, working as assistant professor at Sharad Institute of Technology, College of Engineering, Edra, Ichalkarji, and which is placed at Kolhapur district, Maharashtra. Today in this video, we'll see the sensors used in robotic or robots, or you can say robotic sensors. So we'll see the video about this robotic sensor. So let's get started with here. In introduction, if you're talking about sensors, robotic sensing is a branch of robotic science intended to give robots sensing capability so that robots are more human like. The robotic sensing mainly gives robots the ability to see, touch, hear, and move, and uses algorithms that require environmental feedbacks. The use of sensors in robots has taken them into the next level of creativity, isn't it? So, most importantly, the sensors have increased the performances of robots to large extent. It also allows the robots to perform several functions like human being. Yes, this is a type of robotic with visual force of sensors, right? So here we can see the sensors are kind of microphones. This is microcontroller and servo motors, data acquisition here. So these are the ultrasound sensors, acoustic vector sensors, camera sensors, infrared sensors, chemical sensors, etc. Sensor used in robotic sensing over here. If you see the kind of vision sensor, if you talking about for certain robotic application, the type of workstations control using interlocks is not adequate. The robot must take one or more human-like senses and capabilities the work order to perform the task in a satisfactory way. These sensors and capabilities includes vision and hand-eye coordinations, touch and hearing. Accordingly, we will divide the types of sensors used in robotics into so many categories. In that, this is first category, that vision category, we have classified or categorized the sensor. This is one categorized, that is vision sensor, we can say. Here the method is the visual sensing system can be used or can be based on anything from the traditional camera, sonar, and laser to the new technology, radio frequency identification (RFID), which transmits radio signal to a tag on an object that emits back an identification code. All four methods aim for three procedures, that is sensation, estimation, and matching. If you see the image processing, image quality is important in applications that require excellent robotic vision. The robots can gather more accurate information from the resulting improved image. If you see this usage, the visual sensors helps robots to identify the surrounding and take appropriate action. The robots analyze the image of the immediate environment improved from the visual sensor. The result is compared to the ideal intermediate or end image so that the appropriate movement can be determined to reach the intermediate or final goal. And same here, there is second category is that is touch sensors kind, and this is signal processing and touch sensory signal can be generated by the robot's own movements. It is important to identify only the external tactile signal for accurate operations. Recent solutions applies an adaptive filter to the robotics logic. Robot is a logic. It enables the robot to predict the resulting sensor signals of its internal motions and screening these false signals out. The new method improves contact detection and reduces false interpretations. If you see the usage, the touch patterns enable robots to interpret human emotions in interactive applications. Four measurable features you can say, that is force, contact time, repetition, and contact area and change can effectively categorize touch patterns through the temporal decision tree classifier to account for the time delay and associated them to human emotions with up to 83% accuracy. And here is third one is hearing, voice sensors we can say, or hearing sensor. Signal processing accurate audio sensor requires, yes, so low internal noise contributions. And the traditionally audio sensor combines acoustic array and microphones to reduce the internal noise level. Recent solutions combines also piezoelectric devices. These passive devices use the piezoelectric effect to transfer force to the voltage so that the vibration that is causing the internal noise could be eliminated. On an average, internal noise up to about 7 dB can be reduced. And the robots may interpret straight noise as a speech instructions. The current voice activity detections, that is VAD, voice activity detection system uses the complex spectrum circle centroid method and a maximum signal to noise ratio beamformed, right? What would be usage? Robots can perceive our emotions through the way we talk. Acoustic, the linguistic features are generally used to characterize emotions. Sensor used in robotics. The proximity sensor. This type of sensors is capable of pointing out the availability of the component. Generally, the proximity sensor will be placed in the robot's moving parts such as end effectors. These sensors will be turned on at a specified distance, which will be measured by means of feet or millimeters. It also used to find the presence of the human being in the work volume so that the accident can be reduced. And the infrared, that is IR transducers, that is an IR LED transmits a beam of IR light, and if it finds an obstacle, the light is simply reflected back, which is captured by an IR receiver. Few IR transducers can also be used for a distance measurement. That is ultrasonic sensors. These sensors generate high frequency sound waves. The received echo suggests an object interruptions, and the ultrasonic sensors can also be used for distance measurements. And one another is photo resistor. That photoresistor is a light sensor, but it can still be used as a proximity sensor. When an object comes in a close proximity to sensor, the amount of light changes, which in turn changes the resistance of the photoresistor. This change can be detected and processed, right? Now, next is the range sensors. The range sensor is implemented in the end effectors of a robot to calculate the distance between the sensors and the work part. The value of the distance can be given by the workers on a visual data. It can evaluate the size of images and analysis of common objects. The range is measured using the sonar receivers and transmits or two TV cameras, and then it would be get a sense about the distance for the same. If you see again, next one is the tactile sensor. Here tactile sensors provides here the sensing device that specifies the contact between an object and sensor is considered as a tactile sensor. The tactile sensors are often in everyday objects such as elevator buttons and lamps, which dim or brighten by touching the base. There are also innumerable applications for tactile sensors of which most people are never aware. These sensors can be stored into two keys types, namely touch sensor and the force sensor. Right? The tactile sensor provides the robot with capability to respond to contact forces between itself and other objects within its work volume. And as we see here, a touch sensor and force sensors are a type of these. And here the touch sensor are used. Touch sensors has got the ability to sense and detect the touching of a sensor and object. Some of the commonly used simple devices as touch sensors are micro switches, limit switches, etc. If the end effector gets some contact with any solid parts, then this sensor will be handy one to stop the movement of the robot. In addition, it can be used as the inspection device which has a probe to measure the size of a component. And these touch sensors are used simply to indicate whether contact has been made with an object or not. A simple micro switch can serve the purpose of a touch sensor, and the stress sensors are used to measure the magnitude of the contact force, and the strain gauge devices are typically employed in the force measuring sensors, isn't it? Here as I means force sensor is including for this calculating the forces of several functions like the machine loading and unloading and material handling and so on that are performed by the robot. These sensors will also be better one in the assembly process for checking the problems. There are several techniques used in this sensors like joint sensors robot, wrist force sensing and tactile array sensing. If you see another is a light sensors. A light sensor is used to detect light and create a voltage difference. The two main light sensors generally used in the robots are photoresistor and photovoltaic cells. Other kind of light sensors like phototubes, phototransistors, CCDs, etc. are rarely used. If you see here, photoresistors is a type of resistor whose resistance varies with a change in a light intensity. More light leads to less resistance, and less light leads to more resistance. These inexpensive sensors can be easily implemented in most light dependent robots. And the photovoltaic cells convert solar radiation into electric energy. This is especially helpful if you are planning to build a solar robot. And although the photovoltaic cell is considered as an energy source, and intelligent implementations combined with the transistors and capacitors can convert this into sensors. And this is photovoltaic cells and photoresistors, right? So next here, sound sensors. As the name of suggests, this sensor, generally microphones, detects the sound and returns a voltage proportional to the sound level. A simple robot can be designed to navigate based on the sound it receives. Imagine a robot which turns right for one clap and turns left for two claps. Complex robots can use some microphones for speech and voice recognition. The implementing sound sensors is not as easy as light sensors because sound sensors generate a very small voltage difference sh- should be should be amplified to generate measurable voltage change, right? And another here is temperature sensors. Tiny temperature sensors ICs provides voltage difference for the change in temperature, and the NTC thermistors can be assembled in the housing in a variety of configurations for temperature sensing, measuring, detections, indicator monitoring, and control. The thermistor temperature sensors probe assemblies can conveniently attach to or be an integral part of any system to monitor or control temperature. The primary factors which determine the optimum configurations of a thermistor assembly are the operating environment, mounting, and time. The application for the temperature sensing includes a temperature sensor, surface temperature sensors, and immersion temperature sensors. Housings for a temperature sensors are often simple, inexpensive devices such as molded plastic shells, deep drawn brass or aluminum cylinders, or even stainless steel tubes as well. These are temperature sensors. Here now, the contact sensors. The contact sensors are those which require physical contact against other objects to trigger. A push button switch, limit switch, or tactile bumper switch are all example of the contact sensors. These sensors are mostly used for obstacles avoidance robots. When these switches hit an obstacle, it triggers the robot to do tasks which can be reversing, turning, switching on LED, stopping, etc. There are also capacitive contact sensors which react only to human touch. I mean, not sure if they react to animal touch, but human touch senses that touch screen smartphones available these days, isn't it? Use capacitive touch screens, not to confuse with the older stylish based models, please, right? Because For that only that mentioned, don't uh, confuse about older stylish based models. And if contact sensors can be easily implemented, but the drawback is that they require physical contact. Touch is very important. That is, contact sensor is itself says that it should be touch or contact, right? Next is, this is voltage sensor. The voltage sensors typically convert lower voltages to higher voltages or vice versa. That is, higher to lower voltages. An example is a general operational amplifier, op amp you can call it, isn't it? Which accepts a low voltage, amplifies it, and generates the high voltage output. Few voltage sensors are used to find the potential difference between two ends, that we called voltage comparator. Even a simple LED can act as a voltage sensor which can detect a voltage difference and light up. Cool. Are you getting this? If LEDs also act as voltage sensor which can detect the voltage difference and light up. If it is voltage difference, that could get light up. And next is current sensors. The current sensors are electronic circuits which monitor the current flow in a circuit and output either a proportional voltage or a current. Most current sensors output an analog voltage between 0 volt to 5 volt, which can be processed further using a microcontroller, right? And these are some sensors are used in robotics. So we have saw one by one robotic sensors, voice sensors or tactile sensor or proximity sensor, touch sensor, stress sensor, voice sensors, and so on. And these are the some robotic sensors. In next class we'll see the next topic of the robotics. Thank you.